Hi all, welcome back to a new lesson. So in this lesson, before I wanted to look into private networking and how that works. Before we jump into the specifics of Azure virtual networks. So very important concept, and I thought it'll be useful for everyone to know how private networking works. Basically, as you all know, the internet has trillions and trillions of devices, your smart home devices, your cell phones, your computers, servers, your corporate network, your data center. So how does and we all know that IPv4 address is limited, right, to a few billion. So how is it that we are able to get so many devices talking to each other, and so on and so forth, right? This is all possible because of this private networking concept, and it is private networks use the three designated address ranges that I've shown on the slide: the 10 dot address space, the 172 address space, and 192 address space. And these are set forth by the IETF RFC protocol 1918. So that means that everybody who is implementing private networks must follow these protocols and use these address ranges. So this makes it possible that a company A and company B can have the same address space, the 10.0.0./8 address space, and it makes it possible for private home networks like myself and your computers, which are connected to the internet through your cable providers, also can have the same address space. And how is that possible? Because of the NAT. The NAT stands for Network Address Translation. So think of it as a device that sits at the boundary of your internet and the public of your network and the public internet, and it acts as a translation layer, which means that all the private IP addresses that are in your network will talk to the outside world through this layer, which has a public IP. So for anybody outside looking in, they only see the NAT's public IP address. They are not able to see your private IP addresses. So this makes it possible that all of these networks have the same IP address but can talk to each other through their public IP, which is attached to the NAT device. And of course, the NAT device, there are also billions and billions of NAT devices, and so yes, IPv4 addresses are facing a big shortage, and that's why we have the IPv6 address, which can support a far greater range of IP addresses. So I hope that makes sense. Let's now look into the details of Azure's private networking. So Azure VNet, or virtual network, is a service that provides the fundamental building blocks for your private network in Azure. So just like you saw in the previous slide, Azure implements the same kind of standards for private networks. As you can see in this diagram, there is a NAT gateway with a 12.5, which is outside the three ranges. So that is a public IP, and that is the one that talks to my home computer, which also has some public IP address, right? So if I'm looking at a virtual network in Azure, I see the 12.5.3.7 and not the IP address of my VM inside my VNet. So like 10.0.0.1. Let's say I have a virtual machine with that address. I don't see that from my home computer. All I see is the NAT gateway's public IP address. So as I said, you can deploy virtual machines, several other types of Azure resources to a virtual network, such as your app servers, your Kubernetes servers, your scale sets, and so on and so forth. You can connect VNets to each other via peering, to the internet via NAT gateway, and to on-premise via VPN or ExpressRoute. So the VPN provides for a private connection over the internet, while the ExpressRoute are dedicated circuits, and we'll look at that later on. And as I mentioned, a NAT acts as a broker or translator between private IPs and public IPs. A VNet in Azure is made up of multiple subnets. And what is a subnet? It's a way to divvy up your virtual network address space into smaller chunks so that you can isolate your virtual machines according to your use case, and that provides better protection. And NAT gateways are themselves attached to a subnet, so you cannot attach it directly to a VNet. And for inbound connectivity to a VM, it needs to have a public IP assigned. So that is a big difference with AWS, where AWS has this concept of internet gateway. Azure does not have that concept. It only has public IPs. So it makes it a little bit simpler. You don't need to have an internet gateway and a public IP. You just need to have a public IP inside your subnet, and that can be and that allows for outside anybody outside in the internet to talk to your your application that is hosted in a VM. So I hope that makes sense. I will see you in the next lesson.